Hey, I'm Chicken Johnny, and you're down in the basement with Chicken Johnny. We're down by the grow room. We all know we have to feed our plants, and we know that plants that are being fed in containers in particular need to be fed. But even the plants out in the field, we have to feed them, and we feed them things like nitrogen and phosphorus and potassium and calcium and sulfur, magnesium. One of the elements we don't think about too much is hydrogen. Yet hydrogen plays an important role in feeding our plants. The pH scale is the hydrogen scale. And we're going to talk about that in just a moment. But first, let me show you what's going on in the grow room. This is my spinach. I've got it on a heating pad. I'll probably shut that off fairly soon. And I have it underneath some grow lights. What I'm actually trying to do with all of that is just try to put together a way to grow seedlings this spring. I'm going to grow a little lettuce this winter along with the spinach, but my spinach is just a test run. I want to see how well those grow lights do. I want to see just how well this location works out. It gets rather cold down here, so I have to run a little bit of supplemental heat for this stuff. And I just want to see how it goes. So let's get to it. Let's talk hydrogen. Hydrogen is the lightest element on the planet. It was the first element discovered, and it's the lightest. It's 14 times lighter than air. The only way to keep hydrogen on Earth is our Creator made a way for hydrogen to bond with other atoms. So hydrogen atoms are bound up with other atoms, and they do that through an electrical system where the protons in the atoms and the electrons surrounding the atoms have a charge, and other elements have a charge, and opposite charges attract. I don't want to get too much into this, but it is important because in the soil, when we measure pH, we are measuring the potential of hydrogen. And what that means is we want to see how much hydrogen we have that's positively charged, and how positively charged is it? How much hydrogen do we have in the soil that's negatively charged, and how negatively charged is it? The more negative the hydrogen in our soil, the more electrons that are swirling around it, the lower the number on the pH scale. Now, if we start getting very few electrons going around our hydrogen atom, then we're going to have a very high number. Now, the scale runs from 1 to 14. From 0 to 14. 0 being highly acidic. Hydrofluoric and hydrochloric acid make the 0 spot. And then all the way up at 14, you have things that are very alkaline. In the middle, we have the neutral spot. It isn't acidic, it isn't alkaline, it isn't basic. That number 7 is our sweet spot. Now, plants can live all the way from about a 5, a little ways past 8. In fact, they'll live beyond 8. They won't live well, and they'll live under 5 somewhat. But when the ground becomes too acidic, or when it becomes too alkaline, eventually the plants will die. But even in that range that they can live, they might not flourish. They may not produce any fruit. Sweet potatoes are sensitive to that. You can get a lot of foliage, but you're not getting a lot of tuber, and that's because you've got something off in the pH. It also has to do with overfeeding nitrogen. But one of the characteristics that are very important. You need to keep your acid level slightly acidic. Most plants are going to do well from about a 6.8, a good example would be sweet corn, down to maybe 6.2, 6.5 is really where we see brassicas and onions doing well, and most of the things in our field will do really well at a 6.5. Blueberries and azaleas need to be down in the 5.5 range to really do well. You can grow a blueberry plant, but you're not going to get much in the way of blueberries unless you've got that acidity. When the pH is between 7 and 6, let's say, the nutrients in the soil become more available to our plants, and that's the real key about pH. As I said, plants can live at various different pHs, but are they truly getting the nutrients they need to survive? So some nutrients are available in highly acidic soil, and other nutrients are available in very basic soil, very alkaline soil. But it seems like all 17 of the nutrients that our plants need, those are available in a neutral or slightly acidic soil if you've been putting a lot of nitrogen on the soil. And I don't mean organic matter. I mean, if you've been putting some commercial fertilizers on the soil and you've been putting nitrogen on at a higher level than your plants need, then you're going to have a relatively acidic soil. If, however, you have been putting a lot of organic material on the soil, that's going to buffer your pH. So as a rule of thumb, when it comes to pH, I test, and I look at my test. If my test runs at about let's say I'm right at 6.5, well then I do nothing in terms of pH. But if I'm pushing up to 7 the spring of the year, then in the fall I'm going to try to adjust my acid levels or my pH. If in the spring I'm pushed past a 7, if I'm at like say 7.5, where I'm going to be growing beans and brassicas and cucurbits and that kind of thing, well, now I'm a little bit nervous, and so now I might put a little bit of sulfur on the ground. Sulfur will help to bring the acidity back into the soil, because I want to bring my alkalinity down so that my acidity can take over. So that'd be about 6.5, bring it down from the 7. It's kind of confusing, and I sort of confused the matter just now. When you add sulfur, you add acidity. So you're going to bring your pH number down. The further down that number, the higher the acidity. So let's not confuse that. If I've got soil that's highly acid, which in my case is going to be it's going to be fairly common, I suppose, to where I have acidic ground. And the reason for that is I have a huge amount of decaying matter in my field. And I also take a lot of nitrogen out of the soil with the plants that I grow and at the density that I grow them. So I need to add nitrogen back into the soil. And if it's a year when I'm adding commercial nitrogen as opposed to organic matter, then I'm going to create an acidity in my soil that my plants aren't going to want to tolerate. So then I'll put lime down on the field. Now another alternative to lime would be gypsum. And I like gypsum better because I can get it for almost free. It just takes a long time to break the gypsum down to where the soil can use it. Gypsum won't break up your clay. I know people have said to me, well, if you've got a real clay soil, put gypsum in it. If you've got a clay soil, put organic matter in it. Gypsum is a mineral. It's not going to break clay up. It's just another mineral that's going to sit tied up in that clay. So if you want to get rid of clay, use organic matter. If you want to bring your acidity down, get that number up, you put gypsum on the soil or dolomitic lime. Both of those will bring your acidity down. So now the next question, and I think this is the more important question. How often should I test? And is this something I should really be worried about? Well, if you're planting in pots or raised beds, I'd be a little bit more concerned about pH than I am out in the field. The problem with pots and with raised beds is if you use them year after year after year, there's no natural process that's taking place in that dirt to sort of eliminate the pH. Now, I'd actually be more concerned about concentrated salts in a flower pot or in a raised bed. So my advice is, if you're using flower pots or raised beds, go ahead and get one of those inexpensive pH testers. Okay, this is the part where I'm going to talk a little bit about pH testers. I'm not going to spend a lot of time on it because, in my opinion, if you want an accurate pH test, send your soil out and get it tested. But for our purposes in the garden, unless you're seeing a problem area, now a couple of hints that you might have a problem. If your leaves are turning yellow, completely yellow, you may have highly acidic soil. Now that's not the only reason that you'd have yellowing leaves, but that might be an indication of an acidic soil. If your leaves turn yellow but the veins stay green, well then that may be an indication that you don't have enough acid in the soil, or that your plants are in an alkaline soil. Also, things like leaf curl can indicate, but you don't know what it's indicating. It could be indicating high acids, it could be indicating low acids, or it could be indicating too much water being put on the ground. It could be indicating a number of other things. Now, rainwater, by the way, carries acids with it. So if you've got a lot of acidic rain, you could eventually theoretically create a problem. When you're watering your pots, now you're going to water your pots a lot more often than I'm going to water my field. You're going to put a lot more water on them. And so you could end up having an acidity problem there. If you're buying good potting soil, you're probably going to be okay. If you're adding organic matter to the top of that pot, mixing it in a little bit, you're probably going to be fine. But an inexpensive soil tester will tell you whether you're within that 6.2 to 6.8 range or whether you're way out of range. So those inexpensive soil testers will give you that information. Better soil testers can be used to get you really close, but usually that means mixing some stabilizers and some chemicals and pulling the hydrogen out of the soil. The hydrogen has to be tested in a liquid solution. If you're testing hydrogen in a solid solution, just putting the stakes into a solid, I don't know of any meter that really works well in that case. But read the instructions on your meter and it'll tell you if you can do that, I suppose. To go out and buy these test kits to do the home tests, I don't think that they're worthwhile. You can usually go to your university extension office and someone in the ag department will be able to point you in the direction of getting a soil test. Soil test usually costs about $20 per test. At least that's what I've been paying. And I actually have both soil tests done. I'll explain that someday. But a cheap meter should probably do the trick, because it's going to tell you the range that you're in. Now what that meter's doing is it's calculating the electrical continuity of your soil, and that's going to give you the potential of your hydrogen. So some of them have 2 stakes, some of them have 3 stakes. I'm not really sure what the third stake does. Some of them only have 1 stake, but they've got 2 different colors on the probe. And so you've got to be careful with those, that you're putting the probe down to the right depth in the soil. There's also ways that you can test it using vinegar and baking soda. I'm going to let you search YouTube for those solutions. I've never done it. I suppose it's going to tell you if you've got acidity that's way out of range, but I don't really trust that type of testing. Well, what I mainly wanted to do is show you my spinach and talk to you a little bit about pH. It is important. You should test your soil if you've never tested it. Test it this year, test it next year. If there's no change, test it in 4 or 5 years. If you're dealing with pots and raised beds, make sure that you're stirring in a lot of new organic matter. That'll stabilize that acid. All right, I'm Chicken Johnny in Mitzrayim. I'll see you again. Eat your vegetables.